Welcome everybody, hello. Welcome to video number 9. And in this video we're going to be talking about the shark's acute sense of smell. And I'm going to tell you about the acute sense of smell, and I'm also going to get rid of a couple of misconceptions when it comes to how well sharks smell and blood in the water, etc., etc. But before we do that, I just want to point out, just in front of the eye over there is one nostril. Whoops. There's one nostril there. And obviously there's another nostril right over there. So they have two nostrils right in front of the eye. It's a great white shark, obviously. Now, the first interesting thing about the nostrils on a great white shark or any shark species is that the nostrils are there for olfactory purposes only. They don't breathe through their nostrils as we do, or other mammals do, or animals that live on land. They breathe through these things over here, the gill slits. So they swim along with their mouths slightly agape. Water flows into their mouth, into this cavity, and flows out of the gills, and the gills absorb the oxygen from the ocean, from the water flowing through. That's how they breathe. Okay, that's how all shark species breathe. That's how fish breathe as well. But fish have all just got one gill slit, where a great white shark has 5. Now, a lot of people believe that, quite correctly, that a shark can smell a very small, a very tiny dilution of fish blood or whale oil or whatever it may be in the water. But where people go wrong is that they believe that if you, let's say there's a shark in the area. Let's say this is a beach. I'm at a beach, okay? And I paddle out on my surfboard and I've got a liter of blood. And 500 meters away or 200 meters away or even 100 meters away or even 50 meters away, there's a great white shark swimming. And I pour that 50 liters of blood into the water, and I'm sitting there in the blood surrounding my surfboard. Now, what most people believe is that that shark that's 100 meters away or 50 meters away is going to come rushing in because there's blood in the water. It doesn't work like that. The shark has to smell the dilution of the blood in the water. It has to actually swim through the water column where the blood is diluted or is mixed with, not diluted, but actually mixed with the water. So what I'm trying to say is that here's a shark swimming, and okay, let me make it even more simple. If you walk past the bakery, if you or I walk past the bakery, and there's a bakery over there, it's 50 meters away, and the wind is blowing from us over the bakery and away from us, we won't smell the bakery, correct? We can't smell the bakery because the wind, the breeze is blowing that beautiful smell of fresh bread and pies and that away from us. But if we walk in 50 meters down from the bakery or 100 meters down from the bakery and the wind is blowing towards us, then we can smell the bakery. And it's the same for sharks. If there's blood in the water over here and the current is running that way, okay, so here's our great white shark swimming, there's blood in the water over here, the current's running that way, and the shark is 50 meters away from the source of the blood, or 100 meters away, the shark's just going to continue swimming because he's not going to smell the blood or the fish juice or whatever it may be. However, if the shark is downstream, then it'll pick up the smell of the blood or the fish juice or whale oil or whatever it may be. And then it'll come up and find the source. So it'll come up the corridor. And that is how we find great white sharks. We go to an area where we know great white sharks exist, such as Seal Island or Shark Island in Mossel Bay, and we anchor the boat. And we anchor in a specific position because we want to have the best chance of attracting a shark to the boat. So here's the island, that's the island over here, and let's say the current is going that way past the island, we're not going to go and anchor our boat over there. We're going to anchor our boat this side of the island, so that our chum corridor leads to the island, and any shark that might be swimming around the island will pick up on our chum corridor and come cruising up to the boat to investigate, to find the source of the smell of sardines and salmon or whatever you're using for bait, or chum, or tuna. You know, we're using different things to attract the sharks to where the boat is. So that is how it works. And what I'm trying to tell you here is that if you throw blood into the water here and a shark is upstream of it, it's not going to know the blood is there. The shark has to be downstream. And that is quite simple to understand. Now what I'm going to just mention is how acute the sense of smell is. It's generally stated that a shark can smell 1 part of blood or 1 part of fish juice in 1 million parts of water. Fine, that is correct, but it has to be in the water column, and as I explained, the shark has to swim through it in order to detect it. It can't detect it from any area, you know, from any direction. But the shark's sense of smell increases with how hungry the shark is. So if a shark is satiated, its sense of smell diminishes. So it's not that interested. But as the shark becomes more hungry, its sense of smell increases. So I've never tested the shark's sense of smell. I've just observed. I know how to bring a shark into the boat. I know that you have to put chum in the water. I know that certain stimulants or certain chum works far better than other chum. We've done all sorts of tests with sardine and with shark liver and with whale blubber and with pig blood, and you name it, we've done tests. And there are certain things that great white sharks really prefer. And right at the top of the list is whale blubber. You put whale blubber in the water, and there's any great white sharks in the vicinity, they're going to come and have a look, and they're going to stick around because they love the smell of whale blubber. But as a shark becomes hungrier, its sense of smell increases, becomes more acute. And some estimates say that if a shark is really hungry, it can actually detect 1 part of fish juice or chum or whale blubber, whatever it may be, in up to 1 billion parts of water. But again, it has to be in the water column, and the shark has to swim through it. So that's how it works. But having said that, there's something interesting, and I'm going to be discussing this more in behavior, but I'm going to also mention it in this video. I have a theory which I came up with, and I am 100% convinced of this theory, and I stand 100% behind this theory. Sharks have non-local communication, and I'm going to explain this to you now. Now, it's not only sharks. I mean, there's many terrestrial animals that have non-local communication. There's even trees that have non-local communication. So tests have been done where a forest fire starts on this side, and the trees kilometers away on the other side of the forest register the forest fire and actually react. And with the right equipment, you can actually record the reaction of those trees. They actually react to a fire. So that's non-local communication. Human beings have non-local communication. It's widely known, a scientific fact, if you spit into a petri dish and you take the petri dish 100 meters away and you put electrodes into it, and then somebody gives me a magazine to look through, and one of the pages will be a horrible, terrible picture of maybe a dead body, and then I'll turn the page and the next one will be a nude woman. My spit in a petri dish 100 meters away reacts the same as I do. So I'm connected to electrodes, and my spit in a Petri dish is connected to electrodes, and they both register, and that's non-local communication. Now, why I'm talking about this is because great white sharks love feeding on carrion, on dead whales. They love feeding on dead whales, and if there's a dead whale in the vicinity of great white sharks, guaranteed the sharks will be there feeding on the whale or feeding off the whale. But that whale can be drifting out in mid-water, and a great white shark will find it because the whale will be decaying, and there'll be a oil slick that can stretch for miles and miles and miles, and a great white shark will move up that oil slick to the whale and start feeding on the whale. But then other great white sharks will start moving in, but they don't necessarily have to swim through that oil slick that's coming off the whale. They'll come in from different directions. They'll just know the whale is there. And the reason they're coming from different directions, and in that case don't have to swim through a chum corridor or don't have to swim through a dilution of the whale's oil in the water, is because the vibes that the first great white shark is producing and giving out tells the other sharks in the area that there's action over here. And those sharks will come in based on the vibes that great white shark, and then another great white shark might move in and start feeding on the whale, and they give out vibes. And that is non-local communication in the water. And that can draw other animals in without them necessarily having to swim through the chum corridor or the oil slick that the whale is producing, or the dead whale is producing. So that is what I can tell you about smell. The smell is extremely acute. In normal circumstances, a shark will only find a source of food in the water if it swims through the chum corridor or the oil or the blood or whatever it may be, and gets a dilution of whatever is in the water into the nostrils. And molecules, I'm talking about molecules, into the nostrils, and then it'll start following and tracking its way up to the source of the carrion or the boat chumming or a fish bleeding or whatever it may be, or injured seal or dolphin, anything like that. But then they can also detect carrion through non-local communication. And not only carrion, a great white shark could find a large school of fish, for instance, and start chasing it and feeding on this fish. And it'll put out a vibe which other great white sharks in the area will pick up on, and they'll come in and they'll also feed on whatever that shark, the first shark, is feeding on. So that is what I've got to say about smell. It's interesting, but for me the most interesting is this non-local communication, which is part of their behavior. So anyway, thanks for that, and I'll get you on the next video.